to uh, to cover all of this learning objective once you have completed the subtopic. Okay, all right. So this is one of the most important subtopic in topic 1. Okay, stoichiometry. And to be specific, okay, the limiting reactant is the one that I would consider the heart, okay, the heart of topic 1. By heart, maksudnya it will be coming out in the exam, definitely. Okay, it will be coming out in the exam. Okay, so stoichiometry, I'm sure that you are already familiar with the word stoichiometry. Okay, it is the mole to mole ratio linking substances involved in a chemical equation. Okay, all right. So we have a chemical equation. So the relationship between each reactant and product, or reactant and reactant, or product and product, is called stoichiometry. Okay, so it is a mole-to-mole relationship, and it can be used to help us to solve stoichiometry problems. But before we can do that, we have to make sure that the equation must be balanced first. Okay, all right. Okay, limiting reactant. Okay, in any reaction, one reactant may limit the amount of product formed. The term limiting reactant itself, reactants mean it is the starting material, okay, that used in the in a chemical reaction, okay, and then limiting means substance that limit the reaction. Okay, so in any reaction, one reactant may limit the amount of product formed. The limiting reactant will be completely used up in the reaction. Okay, the reactant that is not limiting is called excess reactant. Okay, excess reactant means at the end of the reaction, some of the reactant will be left over. Okay. All right, so there are two terms that you should know and make sure that you are able to define them. Okay, all right, so limiting reactant is a reactant ataupun substance that limit the reaction. By limit means when the limiting reactant, okay, when the limiting reactant is totally consumed during the reaction, that means what will happen to the reaction? The reaction will automatically stop because there is not enough reactant to be used in order to produce the product. Okay, maksudnya reactant that finish first, okay, that being consumed first in a reaction. So one will finish earlier than the other. Okay, that means the other reactant will become the excess reactant. Okay, so satu banyak, satu lagi sikit. So the remaining is called the leftover. Okay, ataupun the leftover come from the excess reactant. Okay, come from the excess reactant. Okay, look at the example of reaction here. Okay, we have 6 mole of hydrogen react with 4 mole of chlorine gas. Okay, 6 hydrogen gas reacts with 4 moles of chlorine gas to produce 8 mole of HCl. Okay, in aqueous state, and 2 hydrogen gas. Okay, all right. So from this reaction, we could see that chlorine is the limiting reactant. Okay, chlorine is the limiting reactant, and hydrogen is an excess reactant. Okay, because as you can see at the end of the reaction, there is a remaining ataupun leftover of hydrogen gas. Okay, there are 2 mole of hydrogen gas that remain after the reaction has finished. Okay, so we have this. This is the product that we want, and this is the remaining ataupun leftover of the excess reactant. Okay, all right. So this is in terms of diagram. As you can see, we have 4 mole of chlorine gas, and we have 6 mole of hydrogen gas that can be represented by the white molecule here. Okay, all right. So these two will combine, okay, to produce HCl. Okay, all right. Somehow chlorine apa nama tu habis dulu, okay, and we have remaining of hydrogen gas at the end of the reaction. Okay, the calculated amount of product is always based on the limiting reactant. So the product form, okay, the amount of product form will be based on the limiting reactant. Because limiting reactant limits the reaction. Okay, once it is totally consumed, that means the reaction will stop. And the production of product will also stop. Okay, so the product form will depend on the limiting reactant. All right, okay, so that's the idea of it. Okay, so this several terms that you should know. Okay, percentage yield. What does it mean by percentage yield? Percentage yield means actual yield divided by theoretical yield. Okay, actual yield is the one that we got from the experiment, okay, over the theoretical yield. Theoretical yield is the product, the amount of product that we got from our calculation. Okay, so by theory ataupun theoretically, how much product can be formed times 100. Okay, the final answer should be in percentage. Okay, so theoretically, the maximum amount of product that can be obtained by a reaction from given amount of reactant. As for the actual yield, amount of product from experimental determined. So actual yield normally would be lesser than the theoretical yield. Okay, the real one would always be apa nama tu less lah. Okay, would be less than the theoretical yield. So theoretical is based on theoretical lah. Okay, excluding other factors. Okay, which allow us to determine the maximum possible of product that can be formed from the reaction. Tapi is it possible? For example, you want to bake a cake. Okay, you are expecting to produce, let's say, from your ingredients. Okay, you expecting to have 7 cakes. Okay, to bake 7 cake. So for your final product, that would be your theoretical yield. You were planning to have that 7 cakes lah at the end of your baking, but somehow you only managed to get 5 cake. Okay, because one of the problem may be apa nama tu your oven. Okay, your oven is somehow broken. Okay, rosak. And then what else? You punya telur, okay, telur, your eggs, okay, pecah, okay, accidentally. So those factors, okay, may affect the production of your final product. Okay, that will be an example of why actual yield sometimes, okay, has lesser amount than the theoretical yield. Okay, theoretical yield is based on prediction. We can calculate the yield based on the information that we have at the time. Okay. Okay, the actual yield cannot be more, so definitely it cannot be more than the theoretical yield. Tak boleh. That is one of the indication that tell us that if you got your actual yield more than the theoretical yield, that means your calculation is wrong somewhere. Okay, so the calculation may be done in either grams or mole. Okay, the unit can be in grams or moles. Okay, so how to solve problems related to limiting reactant? Okay, all right. Determine the number of moles of each reactant. First, you have to determine the number of mole of each reactant. That's the first step. Okay, and then secondly, you have to compare the number of mole of product from each reactant to determine the limiting reactant. This is where the stoichiometry comes in. Okay, you have to compare again. I would like to remind you ataupun I would like to highlight this item number 2. Okay, point number 2, because many of the students at first, at first they tend to compare without compare secara not stoichiometrically. Okay, not stoichiometrically. They're based on the number of mole of reactant saja, that's all, and then compare. Okay, so please do not do that. Okay, you must compare the number of mole of product from each reactant to determine the limiting reactant. Okay, all right. For example, you have A, B producing C. Okay, so you have to compare the mole of B, okay, with the mole of product C then that can be produced. Okay, that is one, the first step. And then the second step, you need also to compare the number of mole of A, okay, how much product can be formed from A, from reactant A. Okay, so that means you have two steps here. Okay, you have to compare for both reactant. Okay, for B, how much will the product form from B? Okay, how much C can be formed from B, and how much C can be formed from A. If you have extra another reactant, maybe this is Z. Okay, so the same understanding we apply for Z. Okay, so that means you have to compare how much Z, okay, how much Z is needed in order to produce C, the product. Okay, tu maksud je item number 2 ni. Bukan just calculate the mole and then compare which one is the smallest. Don't do that. Belum. Itu tak stoichiometry. Di mana stoichiometry ni? Stoichiometry, you have to compare, okay, mole of the reactant and mole of the product. That is what we call stoichiometry. Okay, then the third one is to convert the number of mole of product to mass of product. Okay, this is dependent on the question. Okay, if the question is asking for mole, then you may stop at the mole stage. Okay, if the question is asking for the mass of product, that means you have to convert from mole to mass. Okay, alright. Okay, so let's have an example. Cuba tengok contoh. A 28.6 kilogram of carbon are allowed to react with 88.2 kilogram of titanium dioxide in the reaction below, and 42.8 kilogram of titanium are obtained. Okay, all right. So given the masses for all the reactant and all the reactants and product. So in this case, our targeted product is titanium. Okay, so you may be asking, madam, we have two products here. So which one is our focus? Okay, all right. So read the question again. Okay, dia mesti ada out of the products produced, mesti ada the targeted product. Okay, in this case they mention titanium are produced, so automatically titanium would be our targeted product. But that does not mean if we are using carbon monoxide, okay, we will get different limiting reactant or excess reactant. Tak semestinya. Bukan tak semestinya, tidak begitu. Okay, bukan begitu. Okay, either you comparing with the titanium or carbon monoxide, you will still get the same limiting and excess reactant, because after all is the same reaction. Mana boleh untuk carbon monoxide we have different limiting reactant than the one that we have for titanium. Tak boleh macam tu. Okay, the limiting reactant is the limiting reactant determination is applicable for all the product lah. Okay, for all the product, for the reaction in particular. Senang cerita, dalam reaction tu hanya ada satu je limiting reactant. Okay, so far for your level, okay. We can have more, but as of now, kita target untuk satu limiting reactant saja. We have to determine the limiting reactant. So the question is asking for calculate the limiting reactant, theoretical yield and percentage yield. Okay, alright. So in order to calculate the limiting reactant, you have to know which one is the limiting reactant. Okay, which one of these two reactant is the limiting reactant? Kita kena determine that first using the steps that we have learned here. Okay, alright. Okay, cuba kita assign all the masses to the respective reactants and product. Okay, alright. So carbon we have 28.6 kilogram. Titanium dioxide, okay, titanium oxide. Okay, so boleh namakan dia titanium 2 oxide. So we have 88.2 kilogram. So titanium is the product. So we have 42.8 kilogram. Okay, alright. So the mission is to find the limiting reactant first. Okay, alright. So this is the plan. Okay, like I said just now, we have to determine for both reactants. So we have two reactants, kan? Okay, we have to check on for this amount of carbon, how much ataupun what is the amount of titanium that will be produced. Okay, this is the actual yield. Sebelum nak cakap tu kan, this is the actual yield. Okay, this is the actual yield. Maksudnya through experiment conducted, okay, we managed to get 42.8 kilogram of titanium. Actual kena tahu. Usually the one given is the actual yield, unless you are asked to find the actual yield given other information lah. Okay, alright. So that's why here, as you can see, we have to check for carbon, okay, and how much titanium can be produced from the amount of carbon given. And the same approach kita go for titanium oxide. See? Okay, so we want to calculate with the amount given, okay, how much of titanium can be produced. Okay, how much of titanium can be produced. And then, okay, so we have two information there. Kita ada dua information dekat situ. Okay, what next? Okay, next is to compare between these two product of titanium, which one has the smallest amount of product form. Okay, which one will produce the smallest amount of product? Yang mana satu? So the one that produce the smallest amount of product, the smallest amount of titanium, that means, okay, that means this reactant, okay, mana satulah, mana-manalah, salah satu katakanlah titanium oxide produce the least amount of titanium. Okay, that means titanium 2 oxide is the limiting reactant. Okay, jangan pergi cakap titanium is the limiting reactant. Remember, titanium is the product. Okay, we want to determine the reactant. Which one between these two is the limiting reactant? So in this case, it will be, for example, ni contoh. Kita kena buat calculation dulu. Katakanlah titanium 2 oxide. Okay, titanium 2 oxide. That is how you determine the limiting reactant. Itu dia punya default calculation dia tu. Memang macam tu. Just follow through saja. Okay, right. Okay, cuba kita tengok Okay, kita calculate. Okay, so kita kena calculate for carbon and also for titanium oxide. Okay, so we have the mass in kilogram. Okay, so this is dimensional analysis. Okay, so we have to convert into gram. Why do we need to convert into gram? Because the molar mass, okay, is in gram. You can also convert the molar mass into kilogram, but let's just not do that. Okay, sekarang leceh sikit. Kita convert the mass into gram. Okay, that's why we have this conversion factor here. So this one should be kg carbon. This one also should be kg carbon at the bottom. Okay, all right. So the unit can be cancelled out. Okay, at the top we have 1,000 gram. Okay, 1,000 gram of carbon. Okay, this is just a conversion. Nak convert from kilo to gram. So this is the relationship that we have. Okay, 1 kilogram is equal to 1,000 gram. Okay, all right. So we have the mass in gram already. Next, okay. So we want to find the mole of product. Okay, so we want to find the mole of product. So gram. Okay, so up here we have gram. So at the denominator for the next conversion factor should also be in gram of carbon. Okay, it should be gram of carbon. So this one later on will be cancelled out. Okay, so we have the molar mass, gram. Okay, gram would be the molar mass, the atomic mass of the carbon. So if we have the mass of carbon, okay, so at the top here, okay, for the nominator, we should have 1 mole of carbon. So that is the relationship. Okay, for 1 mole of carbon is equal to 12 gram of carbon. Okay, so this is our conversion number 2, and then this one will be cancelled out. Next, okay, we have mole of carbon there, and then below here should be mole of carbon. Okay, so like I said before this, okay, you should know what you want. Okay, at the beginning we have the mass of the carbon. Okay, at the end what we want is the titanium. Okay, it can be in the form of it can be in mass, or it can also be in mole. Okay, alright, so let's just stop at mole lah. Kita stop dekat mole. Okay, so this is the part where you introduce the titanium. Sebab at the beginning kita ada carbon, last kita nak titanium. Okay, so this is the part you introduce titanium in the conversion factor. So what do we have for the relationship between carbon and titanium? So we can get this from the balance equation. So balance equation can also be our conversion factor. Okay, it can also be our conversion factor. Okay, so from the equation we know that 1 mole of titanium, okay, is produced from 2 mole of carbon. Okay, so that is the relationship that we have. So 1 mole of titanium, below here should be mole carbon kan? Alright, so it should be 2 mole of carbon will produce 1 mole of titanium. So this relationship we got from the balance equation. So this is the mole of titanium. If you want to proceed further, okay, until you have the mass of titanium, then go ahead. Okay, tak ada masalah. Tapi if you can stop at mole, boleh just stop at mole, and then later we can compare in terms of mole. Okay, alright. Next, titanium oxide. Okay, the same approach. Sama macam carbon tadi, kita buat for titanium oxide for the other reactant. Okay, alright. So proceed. So this is a molar mass conversion factor. This is from the balance equation. From the balance equation, okay, 1 mole of titanium oxide will produce 1 mole of titanium. So this is what we call stoichiometry. Okay, so you have to show. Jangan pandai-pandai terus tukar je the mole. Okay, from the equation it is 1-to-1 ratio. But you still need to show the relationship. Okay, so that is why the mole of titanium oxide later on will be the same as the mole of titanium. Contoh. But you have to prove how did you get that. Okay, how did you get that? So from the stoichiometry punya part. Okay, don't expect us to paham-paham sendirilah. Okay, jangan. Okay, you have to include the relationship between the titanium and titanium oxide. Okay, so this will be the final mole of titanium for titanium oxide. This is for carbon. So from here, you need to compare between these two this value. Which one is the smallest value? Okay, alright. So we have this one as the smallest value. Tengok, compare, and then okay, determine. So this is the smallest value. Therefore, okay, the limiting reactant for this reaction is titanium oxide. Okay, jangan pergi tunjuk this is the limiting reactant. No, this is the product. Okay, we use the product to determine the limiting reactant. Sebab student kau punya common mistake is itulah dia dah kira and then dia terus bagi arrow limiting reactant. Okay, so for that mistake you will lose 1 mark. 1 mark just nak label saja ataupun nak state titanium oxide is the limiting reactant. Okay, alright. Okay, so we are done with the limiting reactant. Next, theoretical yield. So how do we determine the theoretical yield? Remember just now the term theoretical yield means the maximum amount of product. Yield means product. Okay, the maximum amount of product that can be obtained from the reaction. That means through calculation. Okay, alright. So the theoretical yield would be this one. Okay, so that is why once you have determined the limiting reactant, everything later on will be based on limiting reactant. Okay, everything will be based on the limiting reactant. Even the product form pun will be based on the limiting reactant. So this is the maximum product for titanium lah. Okay, the maximum product for titanium that can be formed. Okay, so maksudnya through calculation. So the answer is this. So you need to convert this theoretical yield. Okay, how do you find theoretical yield tadi? So this one, okay, determine from limiting reactant just now. Okay, so the next step is to convert the mole into mass. Okay, theoretical yield. So in this case, dia nak in terms of mass lah. Okay, we can also leave it as mole as dia punya final unit. Okay, but in this case dia nak in mass. Patutnya dia kena specify soalan ni. By right, it need to the question need to specify whether whether the product need to be in mass or mole. Okay, dia kena specify. So katakanlah proceed sampai mass kan, and then proceed further to convert into kilogram. So this is the final answer. Okay, So we are going to choose this one.
Madam,
Yes.
yang apa tu? Yang theoretical
Yield.
tu ambil dari itu kan, maximum kan?
Yes.
Kalau yang
From the
actual
limiting
tu,
reactant, from the limiting reactant. So you have determined the limiting reactant. Okay. Alright. So this would be the yield of the theoretical yield of the product. Okay.
yang actual yield pula madam ambil dari mana?
Actual yield is given. Actual yield maksudnya experiment has been performed. Kita buat ke eksperimen tu? No, we don't. Okay, so obviously the question need to give us that information unless you were asked to find it. Maksudnya other information will be provided lah by right. Okay?
Oh, faham madam.
Actual means you buat that experiment. Tapi kita tak buat kan? So by right the value should be given lah should be provided. Okay? Okay, any other question related to this? Ni kena faham betul-betul sebabnya boleh guarantee it will be coming out in your exam. Cuma how it is going to be asked, itu je. That is the scariest part lah. Ada. Any questions so far?
Miss, ada.
Ya.
Kalau dia nak dalam mall, macam nak buat?
Dalam mall that means kita stop dekat sini lah. You mean the product, is it? The theoretical yield in mole.
Yes.
That means we can just straight away use this value. Okay, if lah, katalah theoretically give the theoretical yield. That means your answer would be 1.1039 times 10 to the power of 3 mole titanium. Faham tak?
Tak payah bagi dengan actual.
Tak payah. Theoretical yield maksudnya apa? Ada saya kena faham term theoretical yield just now. Theoretical yield is the maximum amount. This one is the percentage yield. Jangan confuse the percentage yield and the theoretical yield. Theoretical yield, okay, yield of the amount of product that can be formed, the maximum amount of product that can be formed, okay, through calculation. Maksudnya daripada calculation tu kita boleh predict how much of the product that can be formed. Maximum. Through calculation, teori kan, semua benda boleh buat kan, tapi theoretically. Actual does not always the same as theoretical. Tu maksudnya, teori boleh lah, theoretically boleh lah, actual tak necessarily be yang kita predict. Okay?
Madam, kenapa theoretical sama actual tu tak sama?
Like I said just now, okay, actual we have to consider a lot of things. Okay, other factors, okay, factor luaran. Contohnya condition, okay, the conditions are not adequate enough for the reaction to take place, okay, ataupun you are missing there is a lot of error, okay, during maybe transferring of the product from another container to from one container to another container. Okay, banyak faktor-faktor luaran dekat situ yang we need to consider. Masa actual tu lah yang betul-betul berlaku, but during theoretical tu kita consider ke that part? Tak consider pun kan. What we do is just calculate without considering apa dia punya factor luar lah. Okay, external factor tu, that is the most important thing when we are performing an experiment. Okay, contohnya you expect people to come to your katalah performance, you buat performance kan, you expect people to come like 100 people will come for your performance, but in reality, okay, 100 orang ke yang datang, tapi itu case yang lain lah, it can be more, it can be less, or it can be more. Tapi for case ni, okay, by right dia tak boleh lebih. Kalau lebih, that means dia tak boleh lebih from the theoretical yield. Okay, kalau dia lebih, that means there is error there. Maksudnya ada campuran of maybe impurities, okay, in the product. Faham tak?
Madam.
Ya, ya.
Apa tu, daripada equation ni kan kita tahu yang titanium dioxide dia react dengan two mole of carbon produce these two thing kan. Apa tu, dan it also means that the carbon also can produce the titanium, right?
Ya.
Okay, lepas tu kenapa kita kena ambil the amount from the limiting reactant tu? Kenapa kita tak nak ambil yang daripada carbon tu?
Because carbon is the excess reactant.
It excess.
Okay? Carbon is the excess reactant. So carbon is not the one who will determine the amount of product form. Dia excess, dia banyak. Okay, the one yang habis dulu adalah titanium oxide. So bila dia habis, it will stop the reaction automatically. The product will not be produced because one of the reactant is now totally being consumed.
Jadi maksudnya sebab kalau titanium dioxide dah habis, jadi maksudnya carbon ni pun dah tak nak buat apa-apa kan?
Tak boleh buat apa, dia lebih pun dah tak boleh buat apa, tak ada function lah kat situ.
Sebab dah tak ada titanium dioxide ni.
Yes.
Okay.
Sebab we want to produce titanium and carbon monoxide as the byproduct lah. Okay, if there is not enough titanium oxide, that means by right there is no reaction that will take place. For example, again, kalau you nak produce cake kan, so you ada you know how much of the flour that you need, gula, telur and whatnot. Okay, if one of the to produce one beautiful delicious cake, okay, you need all of the ingredients tadi lah, ada dia punya measurement dia sendiri. Okay, katakanlah one of the important ingredients such as the sugar, okay, is somehow habis dululah, senang cerita habis dululah. Okay, katakanlah you tertinggal ke sugar tu dekat supermarket ke whatsoever kan, you don't have your sugar there. Okay, so can you produce that complete cake? Maksudnya kena cukup barang-barang tu. You boleh produce cake tapi maybe cake tu tak sedap, betul tak? So to produce a complete beautiful and delicious cake, you need to have all the ingredients. So if one of the ingredient is no longer there, that means you cannot produce that cake yang complete tadi. Okay? Faham tak?
Sekejap mana? Jadi kalau C tu tak habis, C tu pergi mana nanti? Carbon tak habis, dia pergi mana carbon?
Dia ada dalam reaction tu lah. Okay, dia ada dekat dalam reaction tu, dia akan remain in the reaction. That's why we call it as leftover. Dia leftover, dia duduk lah, dia nak gimana, nak berjalan gimana pula.
Jadi kita boleh ke ignore carbon monoxide ni?
Boleh. Okay, because our targeted product is titanium, in this case. Dia mention. Kalau dia tak mention, that means you can choose any of these two. Tapi make sure kalau you compare the same lah. Janganlah compare carbon, you compare for titanium. And then titanium oxide, you compare for CO pula. Janganlah macam tu. You must compare apple to apple. You cannot compare apple to orange. Okay? Faham tak? Okay. Faham ke?
Faham.
Any other questions? Kena dapatkan, bagus tanya soalan. Maksudnya you have to understand, maksudnya secara analoginya, apakah limiting reactant tu. Okay, so contoh-contoh buat kek tadi, buat nasi lemak ke, buat what else, buat air batu campur ke kan, those are all can be used as our analogy, okay, to understand the term limiting reactant. Okay, bila dah tahu, bila ada satu je limiting reactant, katalah sugar tu limiting reactant, maksudnya dia habis dulu, it totally being consumed, that means the rest of the ingredient are all excess reactant. Okay, they are all excess reactant. Okay, so boleh imagine tak dia punya cerita tu, maksudnya dia ada dekat situ, dia tak pergi mana pun, tapi kita cannot proceed with the baking, in this case with the reaction. Okay, kejap lagi kita nak kena tanya pasal leftover. How much is the leftover? of the excess reactant. Okay, tadi dah habis ke theoretical yield? Okay, so theoretical yield means the product from calculation. So this would be the product lah. If you were asked in mole, that means you can stop here. Okay, you can just rewrite 1.109 times 10 to the power of 3 mole titanium. If you were asked to give the final value in mass, that means you have to convert lah the mole into gram or mole into kilogram. Okay, it depends on the question. Okay, one more question. We have just now we need to calculate for the percent yield. So percent yield, this is the formula. So we need to divide the actual yield with the theoretical yield. So actual yield, this is given. Okay, ambil balik. This actual yield, where did we get this from? This one. Ni actually. Okay, nampak tak dia berkait-kait kat situ? Okay, so we got it from here. So kalau you want it to maintain in mole form, that means it's okay. Tapi your actual yield you need to convert into mole lah. Okay, then only it can be cancelled out. Mole. Okay, katakanlah mole of titanium, and then we have bawah pun mole of titanium, the same product lah kan. Times 100. Okay, cancel. And then
Madam,
you have
42.8 tu dah diberi kan dekat soalan kan?
Ya.
47.9 tu dapat dari mana tu yang gram titanium kat atas ni?
This is the molar mass lah. Yeah, the mass for one mole. Tengok conversion factor ni. Kalau duduk macam ni, maksudnya you kalau ni 47.9, where did this come from? Oh, bawah ni 1 mole. Oh, most likely it is the molar mass because it is in gram. Okay? So kalau you nak tengok datang dari mana ni, you kena tengok atas dan bawah so that you can predict. Oh, ini molar mass ni. Macam tu. Ni pun by right kena ada mole titanium. So cancel mole titanium. Okay?
Medium.
Yep.
If they want nak mole, kalau nak mole, kita buat 1/1.1039 ke?
Yeah. Okay.
So nanti jawapan dia beza lah.
Apa dia?
Jawapan dia akan berbeza lah dengan 80.9.
Why must it be different? It should be the same lah. Okay, cuma kan this is ratio kan. Bila ratio, regardless the number kat atas kat bawah tu, kalau dia tak kisah pun atas dan bawah, tapi dia mesti apa orang kata, at the end of the day you will still get the same ratio, which is in this case 0.8 kalau tak darab lagi lah, without multiplication with 100. Okay, you kena dapat yang sama lah. So you have to convert 42.8 kilogram titanium ni into mole, and then this one we have the mole already from here. Betul tak? Okay, so try divide, dapat tak? Patutnya you kena dapat yang sama lah. Okay, cuma number je dekat sini berbeza. This is in kilogram, this is in mole. Okay? Okay, alright. Okay, next. Calculate the mass of NH3 that can be produced from the reaction of 28. Okay, this is another example. Okay, alright. Calculate the mass of NH3 that can be produced from the reaction of 28 gram of nitrogen and 25 gram of hydrogen. Calculate, so ni ada extra sikit soalan. Calculate the mass of excess reactant left over. Okay, calculate the mass of the leftover. We know that the leftover, okay, came from the excess reactant. Maksudnya yang tertinggal, that remain after the reaction ends, okay, that still remain in the reaction, must come from the excess reactant. Mesti datang daripada excess reactant lah, by logicnya. Sebab limiting reactant dah totally being consumed, dah habis. Okay, so there is only in the reaction, by right, there should be the leftover and the product. That's all. Limiting reactant dah habis. Okay, alright. With the same understanding from our previous working solution just now, what we did before. Okay, kita apply for this question. Okay, so we have the equation already. If we do not have the equation, that means you have to you have to write the balance equation on your own. So dia dah bagi information kan, so you can always write the balance equation. Okay, alright. So ni katakanlah dia dah bagi, ni tak bagi ni, tiba-tiba dia dekat solution. Okay, katakanlah you have to construct your own balance equation. Okay, not a problem. Okay, make sure that it is balanced. Okay, so from the information given, kita assign lah, okay, 28 gram of nitrogen. So this is 28 gram. Hydrogen is 25 gram. Okay, so there is no other information given. Okay, tak apa. Dia hanya tanya mass of excess reactant left over. Okay, before we could determine the mass of excess reactant left over. Again, kita nak kena tahu between these two reactant, which one is the limiting reactant. Betul? We need to know that. Then only we will be able to know which one is the excess reactant. If one is limiting reactant, the other one should be the excess reactant. Okay? Bila kita dah tahu excess reactant tu siapa, then only we can calculate for the leftover. Before we could calculate for the leftover, we should know how much of the excess reactant is being used for the reaction. Okay? Excess reactant tu dia masih ada lagi at the end of the reaction, but it is still needed for the reaction to take place. Dia masih diperlukan untuk reaction tu. So we need to know how much is used, okay, in the reaction, so that later we can just simply minus. Okay, original maksudnya at the beginning we have this much of excess reactant. Okay, once the reaction ends, okay, excess reactant dah digunakan, it has been used. So how much is used? Berapa banyak yang digunakan? And then kita minus to get the remaining, baki. Okay, baki dia. So nak tahu baki, you need to have the original sebelum digunakan, selepas masa digunakan. Berapa baki dia? Okay? Alright, so macam biasa, kita akan check for both of them. Okay, we have to check for nitrogen and also for hydrogen. Okay, alright, convert the gram or the mass into molar into mole. So this is the step where you convert the mass into mole. Okay, so this is the conversion factor. So bawah should be grams nitrogen. Ni pun tak bagus kena ada N2, sini pun kena ada N2. So this one will be cancelled out. Okay, so here we have 1 mole. So 1 mole is equal to its mass, 28 gram. Okay, here is the part where you introduce the stoichiometry that we get from the balance equation. But before that, what is the product form? So kebetulan satu je produk kan? So NH3. Okay, so kita nak compare the product. Okay, so this one we got from the balance equation. 1 mole of nitrogen will produce 2 mole of NH3. This is our conversion factor. Okay, where we introduce the ammonia here. Right? Okay, so kita dapat 2 mole of NH3 can be produced from 28 gram of nitrogen. Okay, kena buat stoichiometry ni, jangan stop dekat mole. Jangan compare dekat mole, oh siapa yang paling sikit itulah limiting reactant. Boy, senangnya hidup. Tak semudah itu hidup kita ya. Kena compare in terms of limiting reactant, even though it is a 1-to-1 ratio. Okay, you have to show the stoichiometry punya part. Amaran keras. Okay. Okay. 25 gram. Okay. This is for hydrogen. So this is the part where we convert into mole, and then this is the part, the stoichiometry part that we get from the balance equation. Okay, from the balance equation, 3 mole of hydrogen. Betul tak? 3 mole of hydrogen will produce 2 mole of ammonia. Okay, alright. So this is the mole of ammonia that can be produced from this amount of hydrogen. Okay, alright. Now kita compare. Kita dah ada kan dua-dua. We are going to compare the product form. Between these two product form, which one is the least amount? The least amount is the one that is produced from nitrogen. Ni paling sikit, nampak tak? 2 dengan 8.33. So mana yang paling sikit? 2 lah. Okay, so jangan buat macam ni. Ini adalah contoh yang bagus. Do not put the word limiting reactant ni dekat sebelah produk. Answer scheme ni pun tak bagus juga. Tapi baguslah untuk you guys take note ataupun alert on this is not the one that we want in the exam. Okay? Bila you buat macam ni, sorry, salah. You kena tulis dekat bawah tu, therefore, nitrogen is the limiting reactant. Because ammonia is the product. Ammonia ni produk, bukan reactant. Reactant is, we have nitrogen and hydrogen. So between these two, nitrogen is the limiting reactant. So obviously, hydrogen will be the excess reactant. Betul tak? Automatically. Okay, alright. So ini kita boleh kata this is the, what do we call that? Ini mole product ni untuk yang limiting reactant ni. What term do we use to represent this mole product ni?
Theoretical yield.
Yes. Okay, theoretical yield. Okay, theoretical yield. This is what we call theoretical yield in mole unit. Okay, in mole unit. Okay, you can also further the calculation to for gram. Okay, for mass. Tapi boleh stop dekat mole. Kalau tak nak buang masa banyak, unless dia suruh lah. Okay, you can just stop at mole punya step. Okay, so kita dah tahu limiting reactant. Okay, alright. Next. Dia tak minta pun limiting reactant. Tapi in order to know this, we need to determine the limiting reactant. Okay, BC mencari mass of excess reactant left over. Like I said just now, before you want to know the leftover, the amount of leftover, you need to know how much is being used. Banyak yang digunakan. Asalnya we have 24 gram original. Original maksudnya before the reaction, the hydrogen, the mass of hydrogen is 25 gram. So out of 25 gram, how much is being used? Berapa banyak yang digunakan? So how do we find that? Okay, alright. Again, kita akan based on limiting reactant, of course. Okay, so we have 25 gram, bukan, ya betul, 25 gram of the excess reactant. Okay, alright. In order to know how much is used, we will be based on the limiting reactant. Okay, alright. Menggunakan limiting reactant as our starting point here. Nampak tak? Dia start dengan limiting reactant. Sebab semuanya depends on limiting reactant. Okay, so with this amount of limiting reactant, kita convert kepada mole. Ini step yang sama macam what we have here. Step yang sama. Okay, convert into mole. Okay, nampak tak dekat sini? Dekat sini yang stoichiometry-nya. Yang paling penting sekali. Alright, so we have we want to know how much of the excess reactant actually reacted with the limiting reactant. Faham ya? Tadi antara reactant and product. Now, between the reactant itself, reactant and reactant. Excess reactant and limiting reactant. So, ini kita punya limiting reactant kan? So, from the equation, 1 mole, dah penuh dah ni tak nampak apa dah ni. Okay, from this equation, 1 mole of nitrogen will react with 3 mole of hydrogen. Okay, alright, so up here we have nitrogen. So below we should have nitrogen also lah, mole nitrogen. So at the top we should have hydrogen. So 3 mole of hydrogen. Okay, this one cancel off and then we will end up with mole hydrogen. Okay, ini pun tak lengkap dia punya ni bukan saya buat Okay, 3 mole hydrogen. So cancel, tekan calculator, dapatlah 3 mole of hydrogen. Okay, so initially this 25 gram, when we convert into mole, it is equal to 12.5 mole. Okay, initially this is the amount of excess reactant, which is 12.5 mole. Okay, so the amount of excess reactant used for the reaction is only 3 mole sahaja. 3 mole sahaja yang digunakan. So, in order to find the leftover, okay, 12.5 minus 3 mole of hydrogen is equal to 9.5 mole of H2. So, this amount of hydrogen is remain in the reaction. So, convert into gram. Okay, convert into gram. Tiba-tiba guna cara macam ni pula kan. Convert into gram and then we have the final mass for the leftover. Okay? Okay, question.
Madam,
Yep.
yang mass NH3 produce tu wajib kena buat ke? Sebab macam tak kena mengena.
Mass. Kat mana? Mass NH3. This one.
Ammonia.
You calculate the mass of excess reactant. Kan macam tak pakai kan? Tak perlu pun. Ada pakai ke?
Okay.
Tak pakai tak perlulah.
Tapi
Okay?
soalan
Tengok apa yang kita pakai. Soalan ni minta ke? Tak minta kan?
Tu calculate the mass of
Soalan. Mana? Oh ni ada ni. Aduh, baca soalan sama, awak pun dengan saya pun sama.
Oh, okay, sorry.
Okay, calculate the mass of ammonia. Okay, dia minta. So kena bagilah. So you should include the mass of ammonia. Okay? Any other question? So use this method in finding the leftover of the excess reactant. Somehow nanti you akan discover lah macam-macam cara lah untuk nak dapatkan the mass of leftover ni. Tapi I really suggest you ataupun advise you to use this method, using the limiting reactant as our reference. Okay, nanti somehow ada yang pakai daripada produk lah, from the product dia tolak lah apalah tu kan. Boleh, you still somehow dapat lah tapi dia tak accurate lah. Okay, don't base on product. Product is something that is it can be varies tau. Maksudnya dia variable. Sebab produk ni dia depend like what I said just now, dia banyak factor that can affect the production of the product. If you base on something that is not fixed, that means your calculation may also change. Okay, so that's why based on reactant tu kita tahu how much we add in for the reaction. Kita kira benda tu berapa yang kita letak for the reaction. Tapi produk dia may be different depending on the condition. So that's why dia ada few methods lah untuk, sebab after all this is theoretical kan. Bila you buat calculation nanti you akan discover pakai produk punya style, dia compare product and product, dia tolak product somehow. Okay, ada juga style yang macam tu. But I highly suggest you to use this. Make the what we call that the limiting reactant as our reference. Dia lah penentu, dia like king lah. Okay, bila dia habis orang lain pun tak boleh buat apa kan. So whatever it is, you have to refer to the limiting reactant, especially for the stoichiometry part, in order to determine the leftover of the excess reactant. Okay, alright. Lagi question ada?
Clear, madam.
Okay, clear. Okay, maybe you can try out this question. Okay, cuba very quickly just try out this question. 5 gram, ni senang je ni. Cuma dia tak provide the balance equation. Okay, so we have theoretical yield, the mass of excess reactant left over and the percent yield. Cuba try. Cuba. Ambil banyak ni. Alamak. Okay, tak apa at least kita practice one question. Okay, you dah boleh ready lah for your quiz next week. Oh guys, aduh ya. Stop dulu, okay. Kita ada atom economy. We haven't covered this atom economy yet. Okay, kita kena cover. This is important lah. Make sure to cover all the subtopics first. Okay, atom economy is this is a very short subtopic. Okay, kita ada 4 slides only. What is atom economy? The word economy itself maksudnya menunjukkan something that is related to ekonomi lah. Okay, saving the economy. So in terms of energy, money, okay, and so on. Atom economy, it can also known as atom efficiency. Okay, is the conversion efficiency of a chemical process in terms of all atoms involved and the desired product produced. Okay, so atom economy is used to indicate the efficiency of a system ataupun of a reaction. Bagus ke tak bagus this reaction? Okay, so that is called atom economy. It is an important concept of green chemistry philosophy and one of the most widely used metric for measuring the greenness of a process or synthesis. Okay, so atom economy is one of the indication ataupun can be used to measure the greenness of a process. Okay, proses ni green ke tak green based on the atom economy, the percentage later on. Okay, a reaction can have a high percentage yield, but also make a lot of waste product, cause a low atom economy. Okay, we are not only considering for the high percentage yield. We want the product, we want the product, the yield of the product to be high, but at the same time, we want to save the earth. Okay, we want to save the earth, and then we want to save the energy, we want to save the money, we want the process to be environmental friendly. Okay, low atom economy maksudnya tak bagus lah, low. Maksudnya tak economical. Okay, high atom economy adalah lebih bagus. Both the yield and the atom economy must be considered when designing a green chemical process. Okay, you have to consider these two. Kita nak yield, of course we want our product to be, the amount of product is higher when the process takes place. Okay, and we also want the process to be friendlier. Okay, friendlier as in it saves energy, it saves money, it is environmental friendly, and so on. Okay, all right. So these are the steps how to calculate atom economy. Make sure you have your balance equation, okay, and then calculate the relative molecular mass of each of the product. So for atom economy, we are going to be using the molecular mass. Okay, kita akan based on the molecular mass. Number 3, calculate the total mass of all the product. Take into consideration any coefficient in front of the symbol. So you have to consider the coefficient. Okay, maksudnya you have the, for example, iron, the molar mass of iron. Okay, make sure that you multiply with 4. Kena consider carbon monoxide, totalkan the molecular mass or the molar mass of carbon dioxide, and then make sure that you calculate it with, you multiply it with 3. Okay, and then total up. Tak apa, kita tengok contoh. This is to highlight that you have to consider the coefficient. Okay, the total mass should be the coefficient should be included in the calculation. Okay, work out which of the product are wanted and calculate their mass. Do not forget again the coefficient in front of the symbol. Apply this formula. So this is the formula. Atom economy is equal to mass of useful product over the total mass of products. Okay, so what is our interest product? What is our focus? What is our targeted product? Okay, so that would be your mass of useful product, benda yang kita nak tu, over the total mass of product. Like for example kan, we want iron. Kita nak iron. Okay, so the molar mass of iron, don't forget to times with 4. Okay, divide by total mass of product. So these two are the product form. Okay, so we have to divide with this product including the coefficient. Okay. Okay, contoh. So in a chemical synthesis of calcium oxide, calcium carbonate is roasted in an oven. Calculate the atom economy. The equation for the reaction is given. Okay, so our targeted product is calcium oxide. Sebab dia cakap chemical synthesis of calcium oxide. So this will be our targeted product. Okay, you kena determine sendiri from the statement given tau. So kadang-kadang dia tak highlight kan, this is the main product. No. Okay, sometimes they mention in a form of this chemical synthesis of calcium oxide. So it is understood that calcium oxide is the main product, our targeted product. Okay, alright. So this would be our useful product. Okay, so total, find out the molar mass of calcium oxide, total kan, okay, which equal to 56. As you can see, all of them are having coefficient dia adalah 1. Okay, alright. So this would be our byproduct lah ataupun waste product. Kita nak produce our targeted product, but at the same time we also produce this byproduct. Okay, so this is called waste product. So the total mass, the molecular mass of CO2 is 44. Okay, alright. So mass, so using the atom economy formula, okay, mass of useful product, which is 56 over 56 plus 44 times 100 is equal to 56%. Okay, so 56% ni taklah tinggi sangat, separuh saja kan. So yang paling bagus, lagi tinggi lagi bagus. Okay, the atom economy, the higher the atom economy, by right, the greener the process is. Okay, raw materials are scarce and expensive, and so must be, we have to be careful, okay, so that the raw material, especially those come from the plant, okay, from animal ke apa kan, so kita kena conserve. So kita jangan don't simply waste, okay, the raw material because it is very expensive. Scarce maksudnya sangat-sangat berkurang. Dia makin lama makin berkurang, susah nak dapat. Okay, so advantages of processes with high atom economy are, okay, you can reduce the waste and pollution, and we can also reduce the energy use, reduce the cost, and conserve raw material. So these are the advantages. Okay, if the atom economy is high for a process. Okay, so kalau soalan tanya, give 2 advantages of high atom economy. So this could be your answer. Okay, alright. So we are running out. Kita dah habis dah masa, dah terlajak dah masa sebenarnya. Okay, so please complete the checkpoint. Whatever it is, kita dah cover, itu tak apa. So next week we will discuss the checkpoint. Okay, alright. Any questions so far related
Madam.
to economy? No,
Madam.
Oh sorry, you.
Nak tanya. Kalau dia bertindak balas dengan karbon, macam mana kita nak tentukan sama ada yang hasil terbentuk tu adalah karbon dioksida ataupun karbon monoksida? Kita kena stabilkan sendiri.
Sorry. It depends on the condition lah. Okay, then again dia kena depends on the condition. So to produce carbon dioxide, most of the time the oxygen itself, okay, the combustion, how does the combustion takes place? So normally kalau dia tak cukup oksigen, okay, there is high tendency for carbon monoxide to be formed. So all those information by right, okay, all those information by right should be included in the question. Kalau you were wondering lah. Tapi macam like combustion kan, normal combustion, dia tak mention dia incomplete combustion ke ataupun complete combustion. Tapi understood, okay, it is understood that the combustion is a complete combustion. Like what we have learned for our empirical formula last time kan, yang daripada combustion data tu. So from the combustion data tu, kita boleh kata most of the reaction takes place are complete combustion. Okay, there is a possibility that carbon monoxide can be formed, tapi it is not significant. Ada tapi not significant, dan max might as well not to include it in the question. Okay, tapi kalau you jadi engineer ke apa, you should know lah for that. You kena tahu ada possibility to form carbon monoxide, or what are the condition, okay, for it in order to produce carbon monoxide ataupun carbon dioxide. Okay?
Madam,
Yep.
macam soalan titanium tadi, kalau silap buat equation, saya buat produk dia carbon dioxide, maksudnya semua jawapan kat bawah tu akan salah.
Ya, maksudnya you are not answering the question lah. Okay? Maksudnya calculate the limiting. Okay, kejap. Let me go through the question again. Apa? Allowed to react in the reaction below and kg of titanium are obtained. Calculate the limiting reactant. Okay, so this is just what we call information. Dia bagi je information kan. Okay, the question is asking for the limiting reactant. Okay, you may use titanium or you can also use carbon monoxide. Tak ada masalah. Okay, we can use either two titanium ataupun carbon monoxide. But in terms of theoretical yield pun still not a problem, sebab carbon monoxide can also be used lah in order to determine the theoretical yield. Because whatever it is, it depends on the limiting reactant. Even though dia titanium ke carbon monoxide, it will have the same limiting reactant. Cuma your percentage yield will be you cannot calculate for your basically you cannot calculate for your percentage yield lah. Okay, because you have the actual yield for the titanium. If you are calculating for carbon monoxide, that means you tak adalah the actual yield for carbon monoxide, unless ada satu lagi option, the rest yang atas tu you calculate for carbon monoxide, and then for the percentage yield you go for titanium. Tapi you banyak kerja lah kena buat dekat situ, faham?
Madam,
Ya.
saya rasa soalan dia macam ni, apa jadi kalau dia salah buat equation tu, dia buat produce tu dapat karbon dioksida bukan karbon monoksida. Macam tu saya rasa.
Kalau salah tadi tu soalan tu kata tiba produce jadi carbon monoxide, carbon dioxide bukan carbon monoxide. Okay, itu memang ada that possibility, okay, for equation macam tu, okay, because kita there is so many possibilities kan. So normally, okay, soalan akan provide on that. Okay, soalan akan provide on that. So maksudnya kat sini kan, katakanlah you jadikan CO2 dekat situ kan, tapi dia balance ke? Kalau you buat sini CO2, katakanlah kan, kalau kita nak in terms of balance lah, kalau you memang dah totally salah, that means kita kena separately lah. So tengok you dah based on your calculation tu, is it true that the limiting reactant is still titanium oxide? Kalau you still dapat titanium oxide, you still will be awarded marks dekat situ. Okay?
Okay, thank you madam.
Okay, so kalau sini carbon dioxide kan, so CO2, betul lah ada dua. Tapi carbon ada satu je. Kan? Sini ada dua. Sini bukan. Maksudnya you kena try to balance again lah.
Boleh balance kan?
Boleh.
Madam,
Okay? As long as the balance lah. Tapi itulah isunya begitulah. So akan ada possibility orang akan buat CO2, ada orang buat CO. Okay, bila isu begitu, maksudnya soalan kena lebih bagus untuk nak make sure dia kena product produce tu should be carbon monoxide instead of carbon dioxide. Okay?
Madam, maksudnya kalau nak tahu kena stabilkan equation tu dululah, balancekan dia.
Ya. That is definitely lah. Kena balance. Kalau you tak balance, you cerita bawah tu salah lah. Tak payah buang masa. Memang salah cerita ni. Okay, you hanya dapat kutip markah-markah kesian je. Limiting reactant tu kalau kebetulan you dapat titanium oxide. Dapat lah. Betul ke titanium oxide? Ya. Okay.
Okay, madam. Thank you.
Alright. Ni ada question guys? Okay.
Madam,
Ya?
nanti saya nak video ni boleh tak?
Ya, bayar.
Bayar.
Macam mana saya nak keluar ni? Oh, okay, alright. Apa tu? All the videos, all the lectures video previously those, I have uploaded all in my YouTube channel. Please subscribe. Okay, tak adalah. Tapi saya dah upload lah. Okay. So the latest is yesterday's. Okay, yesterday's video saya dah upload dekat, nak tunjuk ke? Tunjuk lah.
Madam tak nama channel madam.
YouTube tak YouTube. Madam ada channel YouTube tu, tak boleh lah. Okay, your videos. Okay. So dah ada 4 video dah. Alamak, view baru 22, 27, 11. Ni siap tak ada view lagi. Semalam dah upload. Okay, I have already uploaded all the videos for the lecture only lah. For the tutorial and for the lab, I will upload it in the Google Classroom. Okay, only for the lecture.